Start. Welcome everyone. Today we are going to start our new topic, correlation and regression. Myself Mayuri Joshi, Professor of Mathematics in Changukana Thakur, ACS College. First of all, we will decide what topics we are going to cover. Here in this video, we are going to cover the topic for correlation, regression, their functions which are used in Excel and practice questions. So first of all, the correlation is defined with the help of scatter diagram. The given screen defines the positive correlation, negative correlation and zero correlation, which is called as no correlation. The pattern of our graph is defined in this respective graph. X values are defined for the one variable, Y value is defined for the another variable. If we are having some increasing pattern which is defined in the first diagram known as positive correlation, if the pattern is decreased one, then it is known as negative correlation, and if the values are scattered anywhere on the graph, there is no such pattern observed, is known as zero correlation or no correlation. The term covariance is the main term to define correlation, as variance and covariance both are similar in pronunciation but they are different. First of all, we have already seen variance. Variance is x square, which is defined as summation of xi minus x bar bracket square divided by n minus 1. Generally, this n minus 1 term is used for sample variance. If we are using for the whole population, we can keep it as n itself. Hence, the covariation term is nothing but the which is defined for x as well as y. The formula for covariance is summation of xi minus x bar into yi minus y bar, summation from 1 to n and n minus 1. The covariance is positive if x increases, relatively y also increases. If x and y are changing in opposite direction, that is if x is decreasing, y is increasing, or if x is increasing, y ultimately goes decrease, hence it is known as negative covariance. If there is no constant relationship between these x and y, where covariance is going to be 0. This is the example of covariance. We can calculate this covariance with the help of these x minus x bar, y minus y bar, multiplication and summation also. This is the problem of covariance. The value obtained by covariance is dependent on size of data, the standard deviation. If the large value, there will be greater covariance. If a small, then there will be small covariance. That is, even if the relation between x and y is exactly same in the large versus small standard of deviation sets. Here, this is what first table defines the higher covariance, where second set is defined for lower covariance. Here we define R. R is nothing but Pearson's correlation coefficient. The Pearson's correlation coefficient is defined by small r, which is defined or formalized as covariance of x as well as y divided by standard deviation of x into standard deviation of y. That is Pearson's R, Karl Pearson's R, we can say. Standardize the covariance value, which gets divided by multiplied standard deviation of x as well as y. You can say x as one variable, y as another variable. Covariance of xy is nothing but defines the sign of x as a sign of r, which is either positive or negative. The r value is defined either in positive 1 to negative 1. That means if R value is plus 1, we can have perfect positive correlation. If R value is minus 1, we can define perfect negative correlation. And if R value is 0, there is zero correlation or there is no correlation. Then the term regression comes. That is, if two variables are correlated, either in perfect correlation or general correlation, we can plot a model which defines or which formalizes one variable in terms of another one. Hence, this model is nothing but the regression model. Here they have said correlation tells you if there is an association between x as well as y, but it doesn't describe the relationship, or the correlation value doesn't help us to predict, estimate another variable if one value of these set is known. Here we have to go for regression one. So regression is nothing but the graph defined for x-axis and y-axis and represented by green dots. This indicates there is a positive correlation. The line which is represented by red and named as y hat is equal to ax plus b is nothing but the linear line, or it is the line which is the best fit of that relation. Best fits means what? This line, the distance from each value to the line is at the minimum one, and this one is known as least square method. The least square method is to find out best line, we have to minimize the sum of square of residuals. Residuals is nothing but actual observation and the line. The difference between actual observation and line has to be minimized. So our model, that is equation of that regression, will be y is equal to a plus b, ax plus b, and y, actual y values we have, so the residual actual values of y and estimated, the calculated values of y hat has to be minimized. Therefore, by minimizing this, we can calculate a and b, which is known as coefficients of that line, known as least square regression coefficients. Now, first of all, finding b, these are the method. This everything is nothing but the theoretical method. Now we will see how to define it with the help of Excel. Here we are going to define some practice data sets. So this is the Olympic hockey teams in 2018, Canada and US. Here the country name, whether they are women team or men team, has been defined. As you have already seen, this is what our Excel window sheet is there. The basic formula you have already seen in previous videos. Okay, so this is what our practice worksheet. These are applied over the filters. This one is known as filter. As I drop it down, I am going to have all the number which is defined. Okay, so team are men team and women team. If I select only men and disabled women, the list will be displayed with only men team. You can see over here there are how many teams are there. 50 number of main teams we have defined along with the out of that 96. This is how we apply the filter command. If I want to see the woman team, just select woman, select disable men and go for this one. So woman team has been defined. This is what the filter applied on the second variable. Now 46 teams out of 96 records has been found. This one is the status bar which we have already defined. In this last one we can see 46 out of 46 out of 96 record has been found. If you are applying any filter, this sign will be displayed. So how to clear that? Either select all and this one, or just go to filter command and clear all the filters. If you want to erase all the filters, again go to filter command and put the filters one. Fine. Now if I want to define height and BMI, if we want to define the correlation between height and BMI or weight and BMI, these are the two variables, as weight is in numbers and BMI is also in numbers. Now I'll select these two variables and put it together. Just we are using these two variables for our reference. I'm using this as Control C and putting it over here, another side. Or we'll just go through this one. R. R stands for correlation. Again we have to go for formulas. Either you can go for from this command formulas, or just go for insert, and insert may we can have this formula chart. If you are not understanding, go to here, insert function. This fx defines the insert functions. Just click on that, you can go for insert function. Now I need to use the statistical function. We can go through by putting our function over here. As in this command I need to use my correlation, so I can type it here, correlation, and just click on go. 3 options will be there. If you are not going to this, just select the category. Category is a statistical, and statistical may you have to search all that functions, and this one correlation. Okay, Pearson's correlation. So here this is what the function dialog box is there, open. Now I need to define first array. Array means first value, that is insert first variable. I am putting my weight as first value. Then I want to define BMI. Just insert all the values from that BMI. Okay, here formula result is already been defined. Just click on OK. You will get directly values of R. This R is nothing but Pearson's correlation coefficient. Pearson's correlation coefficient. It is defined from this function.